Well, let's find dy over dx for this equation that is clearly not a function, and we'll state the slope at that point and at that point. And let's just go ahead and talk about what this means. At the coordinate 1, negative 1, we're talking about that. And the slope at that point would be basically the slope of this tangent line, which is kind of there-ish. And then at negative 1/2, comma 0, negative 1/2, comma 0, here's the tangent line. So let's just go ahead and say one of the answers. This one is going to have a slope that is undefined if looks are truly what they are. Looks can be deceiving. And this one actually is going to have a slope of, looks like around 2, negative 2-ish, but we'll see. Okay, so let's start by finding a derivative. And if you don't want to write this step every time, you don't have to, but I feel like writing it. So putting lots of gaps in there. 3y squared equals 4x cubed minus x. And we're going to take the derivative with respect to x on both sides. Again, we are not multiplying by dy over dx. We are operating on both sides by taking the derivative with respect to x. All right, easy side first, if you want to. 12x squared minus 1. This side is 6y, but because this is an x and this is a y and there's some chain rule involved in here, we have dy over dx. Now, they said find dy over dx, which means get it by itself. So dy over dx is equal to 12x squared minus 1 over 6y. Okay, mission accomplished so far. Now we're going to find the slope at those two specific points. And the first one, of course, is 1, negative 1. So using a different color, I like to draw little squiggly lines to separate my work. We're going to evaluate the derivative at a specific point, and the derivative at that specific point shall be 1, negative 1. So dy over dx, evaluated at 1, negative 1. Notice the notation. We've seen this notation before, briefly. This is where I am plugging in a specific number into a certain expression. It's just a way I demonstrate that. A little vertical line says, hey, I'm about to do something with it. So we're going to plug in a 1 for every x and a negative 1 for every y. So 12 times 1 squared minus 1 over 6 times negative 1. That gives me negative 6 in the denominator. That gives me 11 in the numerator, and that is very close to our guesstimate of negative 2. Ah, lovely, isn't it? Okay, now let's figure out the value of the derivative at negative 1/2, comma 0. You can see where this one's going. We're going to have 12 times negative 1/2 squared minus 1, all divided by 6 times 0, and we'll just stop right there. Okay, undefined. Undefined. Because we're dividing by 0, the numerator is not 0, but the denominator is, therefore our slope is undefined. We have a vertical slope.